Hi everyone. This series of videos is intended to introduce the Analog Discovery Board and the WaveForms software. I'm Professor Ram from the Engineering Department at UMass Boston, and I also run the Ubiquitous Communications and Networking Lab, or UCAN Lab. In this video, we will focus on a few examples using the WaveForms software to interact with our AD2 board. In particular, we will be using the digital I/O pins on the AD2 and the StaticIO tool in WaveForms. I also want to note that you can find much more detail about these tools in the Digilent reference documentation at the link shown here. Let's first take a look at our AD2 board to understand what wires we will be using for digital input and output. You should have a diagram like this in your AD2 kit that you can use for reference, but the labels are also printed directly on the AD2 board. For this video, we will be using the 16 digital I/O pins labeled 0 through 15 on our board. If you look on the AD2, you'll find that the bottom right wire is signal 15 down below here, and the one next to this is labeled 14, just as shown in our reference. Similarly, the top right wire is pin 7. The one next to that is pin 6, just as in our reference here. The other pins are all labeled accordingly. Each of these signals can be used as either digital output or digital input. As output, each signal can be set to either 0 volts, 3.3 volts, or high impedance, which we will talk about briefly a little bit later. Note that these digital signals are not intended to source current for large loads. They are good for things like sending signals, driving an LED, or potentially triggering other high current devices or drivers. When set as input, the wires can be connected to other signals in order to observe whether the connected signal is on or off. The high-low threshold is approximately 1.6 volts, where input signals below this voltage are considered low or off, and input signals above this are considered high or on. Note that you shouldn't have to worry about the peak voltage if your signals are all coming from the AD2, but if you're observing external signals that you've connected to the AD2's digital input, then you want to make sure that you keep these signals under 5 volts. Once we open WaveForms, the welcome screen will have numerous tools that we can use. In the following examples, we will use the StaticIO to control the AD2's digital input and output. So let's start our WaveForms software and try to look at a few examples. Remember that WaveForms looks for your hardware on startup, so if you get this notification that says no devices detected, you want to make sure that the USB cable on your AD2 is connected to your hardware, and then select Retry in order to access the WaveForms welcome screen. When we select our StaticIO tool, we open a window with 16 indicators for each of the signals labeled 0 through 15, just as we see on our AD2 board. All of the pins are set as inputs by default, and none of our wires are currently connected to anything, so all of the input signals are seen as low, and accordingly the indicators appear off. The first thing that we can do is change pin 15 to a digital output. If we click on the number 15, we see a drop-down box with a few options. The default input configuration shows up in this drop-down menu as LED, and the dot next to LED tells us that this is what the pin is currently set to. For simplicity, we'll start by making this a button that can either be 0 or 1. This means that the signal is off, or 0 volts, when the button is not pressed, and on, or 3.3 volts, when the button is pressed. The indicator in the top right of the 15 box, up here, shows the current status of the pin, and we can see the indicator turns red when we push the button to turn the signal on. Let's now use one of our mail headers to actually directly connect pin 7 to pin 15. In waveforms, we still have pin 15 as a digital output and pin 7 as a digital input, but now when we push the button for pin 15, we notice that the indicator for pin 7 also turns on. Let's now assume that we have 3 pins connected together. We can do this by using a male header and putting 3 wires on the same row of our breadboard. In this case, we're going to use pins 6, 7, and 15. If we keep pins 6 and 7 as inputs, then pressing the button for pin 15 turns on all 3 of our indicators. If we now want to have control of 2 pins, we can also set pin 7 to a button with options of either 0 or 1. In practice, we typically don't want to have a high and a low connected to each other directly, so this could be a problem if we push one of the buttons while the other is released. Luckily, the 82 actually has internal hardware to prevent this from harming the board, and we can see that pressing either of the buttons turns on the indicator for pin 6, but not the indicator for the other button. Now if we change our buttons to be high when pressed, or Z, which implies high impedance when released, then pins 7 and 15 will actually follow the other when they're released. We can now see that pressing either button actually turns on the indicator for all 3 of these pins. Another option in waveforms is to use switches to keep the digital output set rather than needing to keep the button pressed. We can set pins 15 and pin 7 to a 3-state switches, and then change the switch value in order to actually observe the same thing that we saw with our buttons. We can also use the digital output to interact with hardware like a simple LED. As a quick reminder about LEDs, or light-emitting diodes, these are diodes that convert electrical current into optical power. What's relevant here is that these are diodes, and accordingly that polarity matters, meaning that current only flows in one direction through our LED. The LED has an anode and a cathode, and the LED turns on when our current flows from the anode to the cathode. Looking at our LED here, we see the cathode as the wire nearest this flat edge. This is usually the shorter wire. The other wire, usually the longer wire, is our anode. So let's connect our anode to pin 5 and our cathode to pin 13. In waveforms, we can now set both of these pins to push-pull output switches. And now when we set pin 5 to high and pin 13 to low, we notice that current flows through the LED and it actually turns on. If we set both to low or both to high, the voltage on both sides of our LED is the same, therefore current does not flow through the LED and the LED remains off. Lastly, if we set pin 13 to high and pin 5 to low, then the diode's polarity prevents the LED from turning on and prevents current from flowing in that direction. The last example that we will show is using the use of a digital I/O bank, or a set of I/O pins. If we select the DIO label over here to the left side of one of these rows in waveforms, we have the option to control the entire row. In this example, we will use pins 0 through 7 as input in the form of a 7-segment display. Note that pin 7, which is actually the 8th input, sets the decimal place here. Similarly, we're going to set pins 8 through 15 to output push-pull. And then on our AD2 board, we're going to directly connect pins 0 through 7 to pins 8 through 15, respectively. I've already connected some of our pins. Here, directly, where we now have pins 0 through 4 directly connected to pins 8 through 12 using this male header. We can also connect pins 5 through 7 to pins 13 through 15 on our breadboard. Taking these top 3 pins, 5, 6, and 7, and connecting to our bottom 3 pins, which is 13, 14, and 15. Now we can actually use the output signals from pins 8 through 15 to control our virtual 7-segment display. This wraps up our intro to the AD2's digital I/O and the WaveForms StaticIO. In the next few videos, we'll actually explore the use of WaveForms' waveform generator and oscilloscope in order to generate and observe some analog signals.